Hello students, welcome to class 11 physics. In this video we are going to discuss the kinds of multiplication operations for vectors of chapter number 6, work, energy and power. Explain the kinds of multiplication operations for vectors. So basically there are two types of multiplication of vectors. The scalar product, which is also called as the dot product, and the vector product, which is also called as the cross product. So first of all, let us discuss about the scalar product. If the product of two vector quantities results into a scalar, then the product is called the scalar product. This product is also known as the dot product. The scalar products of two vectors, vector A and vector B, is denoted by vector A dot vector B equals to AB cos theta. That is modulus of A vector modulus of B vector cos theta, where A and B are the magnitudes of A and B vector respectively, and theta is the angle between the vector A and vector B. Now let us see the formula for the vector product. If the product of two vector quantities results into a vector, then the product is called as vector product. A vector product is represented by keeping cross sign between two vectors. Hence it is also called the cross product of the vectors. Suppose theta is the angle between vector A and vector B, then its vector product is vector A dot vector B equals to modulus of A modulus of B sin theta unit vector n. That can be written as AB sin theta n cap, where n cap is the unit vector in the direction perpendicular to the plane formed by vector A and vector B, and A and B are the magnitudes of vector A and vector B respectively. So here when we multiply the two vectors and if it gives the scalar product, then its formula will be simply AB cos theta, where AB are the magnitudes. Theta is the angle between A and B. And when we multiply two vectors and the resultant we get as the vector product, then its formula will be AB sin theta, as well as here because the result is vector, it will be having the direction. So to mention the direction over here, we will be using n cap. We have taken n cap because these unit vector, that is the direction, is perpendicular to the plane formed by A and B. So students, you may note down this theory. Explain the geometrical interpretation of scalar product of two vectors. Suppose the scalar product of two vectors, vector A and vector B, is given as in figure A. So here as you can see in the figure A, we are having two vectors and the angle theta is between two vectors, that is theta is angle between vector A and vector B. Suppose the scalar product of two vectors, vector A and vector B, is given as in figure A, then vector A dot vector B is equals to modulus of A modulus of B cos theta, or it can be written as AB cos theta. This is the scalar product, where theta is the angle between vector A and vector B. This product is shown in two ways. According to the figure B, draw a perpendicular from the head of B on A resulting OM, which is shown as in figure OM is the projection of B onto A, or it is called the component of B in the direction of A. So here let us see. Already we have seen this is vector A, this is vector B. So now taking the projection of vector B on vector A gives me the component of vector B, that is, let us give it the name OM. So here OM equals to B cos theta. So from O to, let us give this name as Q. Here OQ is vector B and OM is B cos theta. So OM equals to component of B along vector A, because you can see over here the direction of this component of B and the direction of the vector A both are same. So OM equals to B cos theta. Now vector A dot vector B, it can be written as AB cos theta. You can split this and you can write it as A into B cos theta. And here we know B cos theta is nothing but OM, that is equals to A into OM. Here A is what? That is the magnitude of vector A, into OM is what? That is component of B along vector A. So the dot product of two vectors is magnitude of one of the vector into the component of the first vector along the second vector. Component of the second vector along the first vector. Now let us see the method 2. According to the figure C, draw a perpendicular from the head of A on B, resulting ON, which is shown as in figure. ON is the projection of A on B, or it is called the component of A in the direction of B. In the previous figure, we had already seen that we are having vector A and vector B. Here we are having vector B, here we are having vector A, here it makes angle theta. Now in the previous case we had taken the projection of B on A. Now in this case we are going to take the projection of A on B. So this will be ON. So we can say, because we are taking the projection of A on B, these ON will be component of A along B. So we can write over here as A cos theta and its direction is along B. So ON is equals to component of A along B. It can also be written as A cos theta. Now vector A dot vector B equals to AB cos theta. We can write like this, splitting it, B into A cos theta, and A cos theta is ON, so we can write B into ON. Here B is what? That is magnitude of vector B, and ON is component of A along B. So we can write the dot product of two vectors is magnitude of second vector into component of the first vector along the second vector. So in general we can write the scalar product of two vectors is equal to the product of the magnitude of the first vector with the projection of the second vector on the first vector. So students, you may note down this theory.